Hello everybody. So, time for follow-up video to my introduction to probability video. And I think now the right thing to do is talk about some vocabulary, and vocabulary is not by far my favorite thing to do when it comes to math, but we have to talk about vocabulary. We have to know the words that people use and so on. But once we got that out of the way, we'll start doing more examples, okay? But this video I think will mainly be vocabulary. Now, I often don't write out definitions when I teach and so on. I'd rather show you by way of example. And then, of course, you can always look up the definitions or ask for clarification if you need it. Anyway, so that's, my take on it. That's my style. But let's do like this. Okay, so suppose we're going to roll a six-sided die, okay? I talked about that a little bit in the first video I made. Now, doing that, we don't know how it's going to work out when you roll a die. That's why we have them, okay? They give us an element of randomness when we need it. We can't predict the outcome of rolling a die. And as a result, we would call that a probability experiment, okay? I don't know how it's going to work out when I roll a die. All right, so that's what a probability experiment is. Rolling a die, flipping a coin, picking a card from a deck of cards. We talked about that one also. Asking somebody like a survey question, you don't know for sure how they're going to answer. All of those could be probability experiments. Now, next thing is the sample space. The sample space is the set of all possible outcomes. So, in the context of rolling a six-sided die, the sample space, if I could list every individual possible outcome, would be you roll a 1, 2, 3, 4, 5, or 6, at least with the numbers on this die, okay? All right. And an event is any subset of the sample space. So like, of course, rolling a 4 could be called an event, but so could rolling an even number. Anything I can gather from the individual outcomes of the sample space is an event. So roll an even number, roll a 4, roll a 1, or a 2, okay? So the outcomes are the results of individual trials of a probability experiment. Roll a six-sided die. One of these numbers comes up. These are outcomes. And events are any subset of the sample space or collection of individual outcomes. All right. Now, let's see. I think that's most of the vocabulary that I wanted to point out for now. But let's talk about one more thing, and that is complementary events. Okay? And again, I'll show you by way of an example. So consider the event roll a 1 or a 2 versus roll a 3, 4, 5, or 6. Now, what do you notice about these two events? If you combine them together, all right, you get the whole sample space, don't you? I mean, when you roll a six-sided die, either this event is going to happen or that event's going to happen. One of them has to happen. If that's true, if two events make up the entire sample space, then we can say that one event is the complement of the other. Okay, it goes both ways. This event is the complement of this one, and this event is the complement of this one. Okay, and that's just that together they make up the entire sample space. All right, now let's see an example of that. So let's say that in the context of our vocabulary that we started talking about in this video, that the probability experiment is to roll a six-sided die again. And we'll say event E, roll a 1 or 2, okay, is like that. And event E apostrophe, or sometimes when we put an apostrophe on a symbol in math, it's read E prime, but whatever. This event is roll a 3, 4, 5, or 6, okay? Now, all right, I want to see what the probability of an event and its complement have to do with each other, all right? because there's a very basic fact about probability that we'll discover. Well, how would we calculate the probability of event E, which is roll a 1 or a 2? Okay, let's go back to, here's my first video I made, Introduction to Probability. So E is an event, okay. You can calculate the probability that E happens by the number of ways that that event can happen divided by the total number of possibilities. Okay, so let's see. Probability of event E. Well, how many ways can this event happen? Rolling a 1 or a 2. That can happen in 2 ways. I mean, when you roll a dice of all possibilities that could come up, there's 2 ways that this one can happen. You either roll a 1 or you roll a 2. So that's 2 out of 6. That would reduce to 1 out of 3. Okay? All right, so you got a 1/3 chance of rolling a 1 or a 2. What about the probability of the complement of this event, E prime? Roll a 3, 4, 5, or 6. Okay, well that could happen in, 4 ways, right? There's 4 possible ways that this event can happen. Rolling a 3, 4, 5, or 6. That's 4 ways. So that'd be 4, and the total number of possibilities is going to be that there are 6 possibilities. So 4 out of 6, and that reduces to 2 out of 3. Okay. Now, all right, what is the sum of these two? The probability of event E and its complement, the probability of event E prime. Well, let's do a little math right here. So 1/3 plus 2/3 is 3/3, or 1, or 100%. Okay? All right, now, the basic fact about probability then is that the odds of an event plus the odds of its complement will always be 1. All right? That's always how it works out. Now, in fact, the whole sample space, the individual probabilities of every event has to be 1. It has to be 100%. Okay? The odds of getting a 1 plus the odds of getting a 2 plus it's like saying there's a 100% chance that one of these things will happen. All right, so the probability of each individual outcome in the sample space has to add to 1. But in addition to that, the probability of an event plus the probability of its complement always has to add to 1 also. Okay, so let's think of this as the fact that I got 1 there as being a rule, a basic rule of probability. Okay, now this is true for any event and its complement. You don't even have to know what they are. So like maybe we'll run into a situation just to test our understanding of this idea. So suppose that we have a probability experiment. It doesn't even say what it is. Okay, it doesn't say whether it's rolling a die or drawing a card from a deck of cards. It doesn't tell us, but just say there's some probability experiment, some situation where we don't know how to predict what's going to happen. Suppose that events E and E prime are complements of each other. Okay, if the probability of event E is 0.4, calculate the probability of event E prime. Now, what did we say? Probability of event E plus probability of event E prime has to be 1. All right. I know this one. That one is 0.4, right? And I'm trying to figure this one out. Okay, so it'd be like just a matter of solving this equation for the probability of E prime. I know they have to add to 1 because that's a fundamental rule of probability. So let's see, how would we solve for this? We would subtract this 0.4 from the other side. And we'd say, okay, well, here's your answer. It's 1 minus 0.4, which is 0.6. Okay, now I don't know what the event E is, and I don't know what the event E prime is. I just know they're complements of each other. I just know that together they make up the entire sample space, and as a result, their probabilities have to add to 1. Okay? Now, somebody can tell you that's a basic rule of probability, but how did we discover it? Oh, well, I actually gave you an example. I think it's good to think of math in terms of examples. You can read the rules and do whatever you want with those, try to memorize them, etc. But if you see an example, maybe it will stick a little bit better. Maybe you'll remember it and understand it better, right? So let's recap this one more time. Here's an event, here's its complement. Together they make up the whole sample space. We calculated the probability of each of them, and we found that just like the rule says should happen, when you add them together, you get 1.